current is going into node A and the current's going out of node A. Okay, let's define that this current is going out, this current's going in, and that current is going out. Okay? We have VA for this current up here, VA minus VC over 20 ohms plus this current going out, VA over 10 ohms. 10 ohms is that current, which is your I short circuit. Remember the I short circuit is equal to the currents going in. We have 1.8 amps going in. Okay? We replace VC by 9 volts because 9 volts is a 9 volt rise with respect to ground. We'll find that VA is equal to 15 volts. Okay? 15 volts with respect to ground. So from here, from ground, going across, it's 10 ohms to A, going over here, that's 15 volts. But we need to find I short circuit. The current is going through 10 ohms, the 10 ohm resistor. So using Ohm's law, V equals IR. We can divide our voltage 15 by the resistance 10 to get current, which this is your I short circuit. Okay, 15. So your I short circuit is equal to 15 divided by 10, 1.5 amps. All right. Now we found our I short circuit. We found our V open circuit. Now we can find our R Thevenin using this relationship. That your R Thevenin is the ratio between V open circuit over I short circuit. Okay. What is our R Thevenin? R Thevenin is equal to V open circuit over I short circuit. Okay. V open circuit is 30 volts over I short circuit 1.5 amps. That is equal to 30 divided by 1.5, we have 20. 20. So R Thevenin is equal to 20 ohms. Okay. Now that's our R Thevenin. Now we can write our V Thevenin. What's the Thevenin equivalence? What's our Thevenin equivalence? It's a voltage source, your V Thevenin, in series with R Thevenin, your resistance, and then you add back the load. Okay. Okay. Now let's draw one voltage source. Excuse me. Sorry. Voltage source in series with your R Thevenin. So this is your R Thevenin, which is 20 ohms. 20 ohms. And your V Thevenin is 30, which we just found. You have points A and point B. That's point A and that's point B. And then you have your load resistance. That's your Thevenin equivalence of this circuit. So we just simplify this circuit by its Thevenin equivalence down here. Now we can find the Norton's equivalence, okay, by taking our V Thevenin here, we divide it by our Thevenin to find I short circuit, which we have, and that would be the current source. That would be the value of the magnitude of the current source. And we just put our Thevenin resistor in parallel with your current source. Okay? Well, let's do that. So we have for Norton's equivalence, we have a current source, okay, in parallel with your resistor. Okay, that's A, and that's B, and that's your load resistor. Okay, what is the current? It's Thevenin over Thevenin over Thevenin would give you your I short circuit. Okay, what's I short circuit? We found out that I short circuit is 1.5 amps. There it is, 1.5 amps. Those volts, okay, 1.5 amps, and a resistance. Both the same resistance, so 20 ohms. There we go, and that's the Thevenin's equivalence. That's your Norton equivalence. Okay, okay, and Part B wants us to solve for Thevenin's equivalence by removing the independent sources. Okay, now there's a shortcut method to find R Thevenin's for when you have a circuit with only independent sources. Only independent sources. You cannot have dependent sources to use this shortcut to find R Thevenin's. Okay, this shortcut uses a method similar to superposition, but what we do is we want to zero out your voltage source, all your voltage sources by shorting them, and you want to zero out / deactivate all your current sources by opening them. Okay, so let's do that. Okay, so we're deactivating our sources or zeroing them out. Okay, so I just zeroed out our voltage source by shorting it, by replacing it by a short wire, and zero out our current source by opening it. Okay, now we want to find our Thevenin's, your resistance seen from A all the way to B. Okay, now take a look at this part right here. You have a 5 ohm in series with a 25 ohms, which is in parallel to a short wire. Remember that when your resistance in parallel to short wire, this is shorted. So that essentially is not in our circuit anymore. So what you have left is your R Thevenin's is equal to 20 ohms. 20 ohms from going from A. 20 ohms, see, in series with the 10. In series with the 10 ohm resistance. And that is in parallel with your 60 ohm resistor. Okay? And you should find that R Thevenin is equal to 20 ohms. 20 ohms. That's what we got last time, right? 20 ohms. 20 ohms. That's what we done. That's the shortcut. Now the shortcut only works when you have independent sources. Okay? You cannot do this when you have dependent sources. When you use the shortcut, zero out your independent sources by opening current sources and shorting voltage sources. Okay, thank you for watching, and that'll be it.